we still continue with the rule of derivative, and we'll be looking at logarithmic function rule. Like when we have a logarithm function, how do we do the derivative of these kinds of function? Let's say we have a function y equals to the log of x. The derivative, the y over the x of this function, is 1 over x. What we are doing here is we do the derivative of the variable that is x with respect to x, and then it's like saying of x divided by x function. So that's what it means. So let's do an example. Let's do examples. 1. Find the derivative of a equals to the natural log of 7x. Find the a over the x. Solution. The a over the x is equals to, let's differentiate 7x. This, when we differentiate 7x, we have 7 multiplied by 1 over 7x. 7 will cancel 7, and then the a over the x will be equals to 1 over x. That's simple, straightforward. Let's do another example. Let's look for y equals to natural log of 10c raised to the power of 6. Solution. I think this is pretty simple. So we can say the y over the c equals to, let's differentiate this. When we differentiate the 10c raised to power 6 is going to give us 60c raised to power 5 divided by the original function, which is still this again, divided by 10c raised to power 6. This we cancel this, and then we have our dy over dc, which is equals to c raised to power 5 over c raised to power 6. No, sorry, 6c. So c can go, and then we have our final answer as dy over dc, which is equals to 6 over c, because this will cancel, remain c raised to power 1, and then we have c raised to power 6. So let's do another example, the third example, where we have y equals to the natural log of x squared plus 5. So we can do find the y over the x. Our solution will be the y over the x is going to give us, let's look at it, we would differentiate this again, which is going to give us 2x all over the original x function, which is x squared plus 5. Apart from the natural log, we just take that again. This again, we put it as the denominator. So, and that is our final answer. Over the x equals to 2x over x squared plus 5. Straightforward. So let's do our final example, where we have y equals to 10 natural log of s plus 3 2. So there are different ways at which you can do this. We can use product rule, and we can use chain rule. So solution the y over the x will be equals to, so let's differentiate the equation. Let's use chain rule. We bring these 2, bring it out to be 2 times 10 using chain rule, multiply by this equation, which is x plus 3 2 minus 1 all over x plus 3 into square. So that is just using the top, we use chain rule, and then this denominator is as a result of this logarithm, and that's why it's come in to be x plus 3 squared. That is bringing this function down. So we have the y over the x, which is equals to 20 into bracket x plus 3 over x plus 3 square. So we can cancel, so our dy over the x will be equals to 20 over x plus 3. Yeah, and then we can also use product rule. We can use product rule as well. In that case, if we want to use product rule, we just label this as f of x, and then we can label this as our g of x, and then we can use product rule to solve it. But this is a much simpler and faster way to get it solved. Yeah.